So, good morning, everybody. When I got offered the opportunity to give the keynote here, I was really excited. So, why was I so excited to come and speak here? This room really represents all the different roles in energy. And even though we have all these different roles, I believe we have one common commitment. How do we solve the energy challenges in America and globally as well? I've been in the industry 25 years. I've worked in the US, worked abroad, and my main goal is to keep about 100,000 assets, rotating equipment running. Some of those assets are actually 100 years old. And you can ask yourself, with this task, what is it that a corporation, a big engineering company like Siemens need from the science community? So what I want to do in the next 30 minutes, give you a little glimpse on how we see the energy landscape evolving, how we see technology playing a key role in that energy landscape, give you a little glimpse what I see in terms of how can digitalization help us solve those challenges. And then the third point, which I'm really passionate about, what does it take to make it happen? We always talk about technology, but there's also a piece, what does it take? How does the science world, how does research, how does corporations work together to solve these challenges? So, you guys all know about evolution, so there's enough scientists in the room that know how it works. If I look at corporate evolution, it's all about selecting the right technologies. How do I pick carefully, strategically, what's important, and what gives me the corporate and competitive advantage in this really volatile marketplace? And there's lots of proposals out there, there's lots of technologies, and it can't be a random selection. So in this energy landscape that we see today, how do we make the right choices? How do I, as an industry player, make the right choices on technology? How do I make the right choices on capabilities, on resources, to be competitive for products that I will deliver in 4, 6, sometimes even 10 years down the road? And in order to make those right choices, you have to really understand how the marketplace works. And if you look, how does the energy landscape look today? If I showed this picture 40 years ago, probably I would have had a nuclear plant on there. 20 years ago, a gas turbine. Nowadays, for me, it feels like a roller coaster. Twists, turns us upside down. It's really hard to make in our industry those multi-billion-dollar decisions in what technology do we pick and what power generation technology do we install, commission, operate. And please keep in mind, most of the assets that we put out there in the energy landscape for power generation, they will work 30, 40, 50, 60 years. And the question is it just technology that's going to give us a competitive advantage? Is it the business model? Is it going to be large scale? Is it small scale nowadays? Distributed? There's lots of choices. And I can tell you, talking to our customers, large utilities, IPPs, smaller new emerging players in the industry, they all see this the same way. It's really hard to make those decisions, and the question they look out for manufacturers like Siemens is really what technology do you pick and how do you make sure you don't miss one of the emerging trends. So the big question is, how do you stay in business? How do you stay in business in this really challenging environment? And there's a lot of discussion about digitization. Is data going to really turn this industry upside down? And you see lots of new players emerging. We have these discussions in our strategy session. Is an IBM, is an Accenture, is a startup out of Silicon Valley, the new Siemens that's going to put us out of business. But for me, it's all about disruption. And it's about communities, conferences, programs like ARPA-E that really show us what's out there and how do we combine those emerging technologies, how do we transfer it, adapt it, take the best clues out of the digital world, and then implement it in our products. So for me, the power of digitalization is really how do you put that together? And I think if I ask the audience, we probably have 95, maybe 100% of the audience has a smartphone. And you use it for multiple apps, applications in your private life. I can tell you, in the corporate world, we're far away from it. Yes, we use data, yes, we analyze data, but I think the full potential, how you use that connectivity, how that data, we still have ways to go. There's early technologies, early products that we're implementing, but the true potential is really out there. And what I want to do in the next couple of slides is really show you what's out there, some of the early stage projects, and I would ask you, just let your imagination roam and see where we can go. So when we go to what's possible, this is actually a picture of a Category 4 hurricane hitting Texas. Actually, this is Hurricane Harvey last year in August. With the hurricane comes a big storm surge, a lot of rainfall, so the danger of flooding. So this is actually one of our turbines. This turbine is over 100 years old. It drives a pump in New Orleans. So when this hurricane, in the weather forecast was showing the hurricane is coming, they ran the turbine a couple weeks in advance to say, okay, is it working? Is the pump working? Are we going to keep New Orleans dry? And they had a bearing failure. Luckily, we could repair the turbine and get it back into operation before the hurricane hit. But the real potential is, if we had connectivity, if we had remote diagnostics, if we had condition-based maintenance, we could have seen this bearing failure come 6 months in advance. We see it on our advanced turbines where we do the continuous monitoring. But it just gives you a glimpse in terms of what's possible and what is the consequence or the non-consequence that this pump will operate when it needs to operate. So let me take you on a little journey of what else is possible. Let me talk about a project we had in Brooklyn, the Brooklyn Microgrid Project. This is a story about Martha Cameron. She decided in 2010 to install solar panels on a roof. And on a sunny day, she would actually have excess capacity, which she couldn't use. And then they found in the neighborhood, they found like-minded people. They said, I would love to buy that energy from you, use it. Now, how do you get it and distribute it? This is where a small startup out of New York comes in, who said, I got some interesting blockchain technology. I can do that trade. And I believe you guys have heard some of the blockchain pitches earlier this morning. And then you also look at the microgrid. What does it take to control the grid and technology to really distribute it across these smaller neighborhoods? So this is just one example. And we've seen more and more of these decentralized energy solutions. When I walked the floor this morning and looked at some of the showcases, a lot of projects on battery storage. Add battery storage to it. And you can have whole communities being self-sufficient to a degree, but then also you need to see, how do I interact with the grid? How do I make sure the grid is resilient? So lots of application on just, producing your own energy, but also distributing in smaller communities. The other one where we spend quite a bit of time on is really how do we make our turbines smart? And we always call it, what happens if our turbines have a brain? And I believe, who has been in the power industry knows how we've improved the control systems over time, but there's a certain limit to it. And now with AI, machine learning, we have seen quite a bit of advancement on that technology. I'll give you one example. We actually built a project, a wind project in Southern California. 100 turbines, 120 acre mountain terrain. And these turbines run at a very high utilization rate already. But what we found is that each turbine actually has a little bit different power curve. And you can optimize. You take that best turbine out of the 100 and see what does that turbine do and apply it to the other turbines. Now in the past, you would download the data, look at it, and then you see, okay, how do I change the setting on the controls of the other turbines? But this goes even further. This is real-time optimization of the wind farm. And what we get is an increase in yield, in power output, by 4 to 7%. You apply that 4 to 7% yield increase to the installed base of wind turbines globally, you get 35 gigawatt of additional capacity, just to give you a little bit of a glimpse what's possible. And actually, my vision was even going further. You take that and say, okay, the turbine knows when something breaks. And it's not just a signal, it says something is going to break, the main bearing, the gear. It's going to order the technician, order the spare parts. So this is really the merge of the technical data, the performance, but also how do you link it into business processes. And you will see a lot of the R&D that we do goes into these type of research projects that combine the machine learning, the automation, the self-learning, and then also combine that with the business processes. The other technology I'm really excited about is what we call 3D printing or additive manufacturing. And I already saw one printer downstairs. It was the showcases. For us, this is really a technology that can change the way we do business. I said earlier, I got 100,000 turbines in my business that I need to keep up and running. Some of them are 50, 60, 70 years old. How do I keep spare parts for these turbines? The traditional way is I have some inventory. I do a risk analysis. I say, okay, these many parts will break over this period of time. And then I have $1 billion plus of inventory sitting on my books. And that's why we said 10 years ago, 3D printing is a technology that's going to really change the way we do the business. And I admit, we started printing our first parts in 2008. We started serial production in 2015. So we're actually at the R&D stage for 7, 8 years. And why is that? We put the parts, we print metal parts, high temperature parts. Some of our turbine blades see 1,000 miles per hour. They go, is the speed they rotate with. 11 tons of forces pulling on them, 1,250 degrees C of temperature. So you really have to make sure when you print a part, it can withstand those harsh conditions. And there's multiple challenges to solve. I mean, one is the printer. What is the right printer and the right technology for the printer? But it goes far beyond that. It's the powder. How do I have the right powder that can withstand those conditions? It's the process. How do I print? Just to give you an example, we actually print burner tips that go into gas turbines. We take them out of the existing assets, cut off the burner tip, print a new tip on it. Just printing that burner tip takes 24 hours. It's a piece about this high, this wide. So you really need to know, how do I run the process? And the last challenge, and that's really the challenge we're giving to our engineers, but also when we talk to universities, how do you train engineers to design to have 3D printable parts? Because there's whole new geometries that you can actually do that, in the conventional engineering thinking, you would never thought about. And that really drives the technical performance. So that is a technology for us that has a huge impact. It drives better performance of the assets. It helps me save cost and also lead time reduction. That burner tip I told you about, if I replace the burner, 43 weeks lead time. Now I can do it in a week. So for the industry, it has really huge upsides, and this is really where we'll also put a lot of R&D effort into to see how can the technology help us improve our products. The other piece we're really excited about, as I said, our assets, our turbines are all around the world. And I face two big challenges. Some of them are in areas that we don't necessarily want to send our employees to, our technicians. Those are areas that go into civil war, but the people still want electricity. How do you do an overhaul? How do you do a maintenance in these areas? The second big area of my concern is my technician workforce on some of the technologies. The average age is 55, 56, 57. I have this big tsunami of retirements coming. So how do I address that? One is really, how do we do remote outages? How do we do the work remotely? And, if you kind of go very far out, you can envision, is there a robot who does the work and you steer it from, some location, be it in Germany, be it in the US? I think the first step, and we actually got to that almost per accident, I had a big contract in Libya to maintain the power plants. And as you all know, the civil war happened a couple of years back. We couldn't go into country. They had really good plant staff, but we needed to do an outage. Take the whole turbine apart, do fact-finding, exchange parts, and then put them back in. So we actually developed a method how we could have the customer's technicians perform the outage, video cameras, high resolution, picture transfer. We even went a little bit into AR, but it's at a very infant stage. And you just look at an industry that in our industry is really comprised of highly specialized technicians, engineers, who go out to power plants and perform the work. And the world has gotten more complex, more diversified, and we just don't have the workforce anymore to do it. So using these technologies, doing it remotely, doing it together with the customer, also offers us a huge potential to really perform the work and make sure the assets run as needed. Now, for me, the area that I'm really passionate about is really, what does it take to unlock it? I think all the technologies I described, you guys probably say, really boring. We have, worked in our labs on it. It's all there. So what does it take to transfer some of those technologies, bring it into big corporations like Siemens, and have us really apply these technologies in products that we can commercially sell? And a big piece of that, for me, is how we work together. And I think those words you hear up there, it's, you can say, oh, these are all industry buzzwords. We always talked about teamwork. We always talked about collaboration. I think really what I've seen in the last 3 years is really a shift to a more partnership approach. And it's about co-creation. We have seen work with customers where we have traditional, customer-supplier relationships. Customers are sharing data with us. They say, I have this problem to solve. It goes back to the roller coaster I showed earlier. The whole energy landscape, the whole industry is in a state where they see, with the traditional ways of working, I cannot get it. I cannot get there. And what we're doing with our customers, I also believe we need to do far more with this community. How do we go out and interact early on with the science community, with the tech entrepreneurs, look at technology and say, what can help us? And it's not always in the traditional relationships. Yeah, you're a supplier, or you do a research project for us. It's about really the co-creation, partnerships. Some, you can go alliances, you can have JVs, there's all different types of things. But it also takes a lot of convincing in the engineering departments of our companies, both on the customer side and also what I see with us. It's really opening up, trusting other people to bring in the technology, to be a real partner that you trust and that you work with, and really take the technology, take the ideas and apply them. And one big driver is speed. Speed is so essential now to bring your products to market. If I look back, in the past it took about 8 to 10 years to develop a new gas turbine technology, a new gas turbine frame. Cost us about $500 million plus in R&D money. The latest technology that we developed as Siemens took 4 years. We basically half the time it took to develop the technology. One big thing was the whole idea of collaboration and co-creation, how we put the teams together, how we partnered up. The second big piece is what I call intelligent risk-taking. And when I came into this position a year and a half ago, I looked at my R&D roadmap. And the way we do traditionally the R&D roadmap, for each project we ask, give us a business case. And all the business cases were positive. There was no room for failure. People knew if the business case didn't give a positive return, I wouldn't get any funding. But what that also led to is we didn't truly focus as a company on early innovation. And sometimes you have to take bets. Sometimes you cannot really put a business case together and say this is always, going to give you a return. It's also a bet on technology. And I think that's also where this group comes into play. In the future, we will have more and more of these early corporations. Yes, not all the technologies might get to the stage where we, commercialize them and have a product. But it's taking really this intelligent risk-taking approach to get to the space where we need to be and be competitive in this uncertain market space. So, just a hypothetical exercise. So if I gave you a short glimpse on what we do in digitization. There's a whole lot more on cybersecurity, on smart plant trainers, on emissions control. If we just apply it to our entire operating fleet, just the Siemens fleet that we have put out there. Just 3 statistics. Efficiency across the whole fleet would go up 4%. Emissions would go down 30%. And operating life would go up 30% as well. Now this is in a very ideal world. We don't have the products yet. Some is research, but it shows you the true potential. How do we get there with digitization and digital products? And you can say, should we now all learn and go out and learn how to code? A lot of this is a combination of data, of software, and of hardware. And I was talking to somebody in the Bay Area a couple weeks back, and she told me, even out here in Silicon Valley, it started with hardware, it went to software, it goes back to hardware. And she was just holding up her iPhone. She said the smartphone, the first smartphones really enabled the development of all the apps. All the apps were driving more improved mobile phones, better smartphones. And I think in our industry it's the same thing. We have existing assets, we look how we can improve it, but at the end a lot has to go back also. How do we put improved parts, improved designs back into the engine? So to close out, one final thought. You see the diamond here. And when I started my career, for me, the power generation industry was always like a diamond. You had technologies like steam turbines who have been around 100 years. Most of the business models we created were there for a very long time. But in today's world, I don't believe we have the diamonds anymore. For me, it's more like an ice cube. And you can say, maybe the ice cube sits out in the desert and is really melting fast. We have to continuously reinvent ourselves as an industry at an even faster pace. And I think the ice cubes illustrate it. If we don't do that as a company, and Siemens has been in the business 170 years, we'll just be a puddle in the sand. So for us, it's really essential, and that's why I'm so grateful that I could come and speak, is how do we, as the energy industry, solve these problems and evolve at a pace where we can produce ice cubes that might be melting, but we have the next tray of ice cubes that we can deploy and put out there. Thank you, everybody.